Yet another incredible speaker for you. His name is Bing Xu. Bing is currently an applied research scientist at Facebook, as well as a Kaggle Grandmaster, a Grandmaster right in the flesh. Some of Bing's most notable accomplishments include being an early contributor to XGBoost, MXNet, as well as being the creator of XGBoost JL, MXNet.js. And in deep learning research, his major contribution includes being one of the original, generative adversary network GANs and some studies on neural network activations. Let's welcome Bing.
Thank you. Thank you, everyone. And it's a great honor to stand here. And I'm sure you already have a lot of exciting technical talks, and so today I will just share you some relaxing stories about the AI gold rush in past 10 years. And I call myself a wheel maker. It means that in past 10 years, most of my time was spent on making a wheel or reinvent a wheel. So I will bring some of my memories about the past 10 years, mixture with some lesson I learned about the AI gold rush, and especially in a wheel maker's view. So before we start, it's a declaration. This is a personal presentation which doesn't contain any information about my employer to clean up every issue, potential issue. So previously, I planned to discuss about AutoML and Auto-TVM and this auto stuff a little bit more technical, because recently my friends and I, we found out by understand a little bit deeper of how neural network works. We found a microstructure which is able to beat all the reinforcement learning and evolution-based AutoML method in many tasks. So it's very interesting topic. But unfortunately, we won't talk today. Maybe we can talk later, and it will be released in archive today or tomorrow. So let's start. So brief introduction about myself with Kaggle. And there's something not listing in the timeline. It's in 2010. And at that time, I was an undergraduate student. And it's 10 years ago, the hottest topic at that time is mobile. Other people is talking about a mobile app, all kinds of mobile app or iPad app. And I spent a year observing a mobile startup, and seeing how they trying to expand their business and how this industry works. And then after a year, I realized the most important things behind the app is the user and the data generated by the user. So without user and the data, it's just an app, and even for students, it takes a week they can clone an app. So I started to learn to investigating how I can make use of the data. So I download the slides and video from Stanford website, and learn how to modeling social network, and learn some basic machine learning from video and slides. And in 2012, I started to practice in Kaggle. That's my first interaction with Kaggle. And within the first competition I joined is the KDD Cup 12. And at that time, it's my first competition. I know nothing, and I just try to get something working. And my rank is 97 or 600 people. It's a so-so, but it's a very important chance for me to meet a person. His name is Tianqi Chen. He's the main author of XGBoost and a lot of remaining stuff, and we become a good friend since then. So I feel like for Kaggle, competing in Kaggle, a very important experience is making friends. And I met Tianqi in KDD Cup and since then, and we worked very close in many other projects. And then after learning some lesson from KDD Cup, I do more practice in all kinds of competition. I spent almost a year in undergrad just doing all kinds of competitions. And in 2013, it's last year of undergrads, and I attend another competition. It's called Challenge of Representation Learning. It's hosted by Ian Goodfellow, and later we become good friends again. So since 2013, I gradually know how to compete in the Kaggle. I know all the pipelines and how to make a toolkits, how to make a pipeline and get things work and get a good rank. And in 2014, I attended 2 important competitions. The first is the risk business. It's a master-only competition. And in this competition, it's the first time XGBoost showed its muscle. And we will talk about it later. And the National Data Science Bowl is the first competition which deep neural network show its muscle. And so these 2 competitions is remarkable, and they give me a deepest memory of among all the competition I attend. And later I found out that, okay, everyone know how to use XGBoost, everyone know how to make a ConvNet. It's time for me to get retired. So after that, I gradually moved my interest to other stuff, and I spent a little time on Kaggle. But I did make a lot of friends in Kaggle, and we are still good friends, and we are still working very close. So next is about my research. And in 2013, and because I attended a Kaggle competition, and I realized ensemble is very important, so I started to investigating how to do ensemble with neural networks, and I invented a method which is called horizontal ensemble and vertical ensemble, which inspired many later work, get much better boosted neural network performance. And in 2014, and is working on generative adversary net. It's after drink with Ian Goodfellow, and we work on this stuff. And I'm the first people who use GAN to generate the human face. And now when I compare the NVIDIA's result with my result on that year, it's like totally different. It's like just the basic something is able to fly on the sky compared to the modern jet. And yeah, at that time it's still there's no batch norm. Training GAN is super hard. So in 2014, I asked Ian Goodfellow a question: how we can use GAN? I feel like this one is useless. And Ian told me, I don't know either. So in 2014, I spent quite a lot of effort in investigating GAN, but most of the effort failed because at that time, no one really know how to train neural network well. And in 2015, I spent some time in investigating activation function, and I get to understand how we can train a sigmoid network, deep sigmoid network without batch norm. So the secret is we need to initialize and get different learning rate for different layers. So it's quite simple, and then we can train 30-layer or 40-layer sigmoid network without batch normalization. But as the performance is not as good as a ReLU network, I didn't dive deeper to that. But later, like today, people look back, realize that this is probably something important. Like when we try to train BERT in 1 hour, we need a different learning optimization method for different layer. So that's the early stage. And then I did some research on lightweight neural network architecture. And at that time, I can get my stuff running on mobile phone and running JavaScript in web browser. This is just for fun. And I spent 2 years silent at Apple, and I won't talk anything about Apple. You know, you know that the reason. And this year, I'm going back. I joined Facebook, and I started doing some fundamental architecture research. And as I mentioned, we found out a very efficient microarchitecture, and which is able to beat almost all the reinforcement and involution architecture search result. So I think getting understanding of how it works is still very important, although we have even more computation power, we have more data, but it's worth to investigate our energy to understand how it works. So the last piece is about whales. In 2012, I just joined the Kaggle community. I started to learn how other people are doing, and I used liblinear and libsvm. And at that time, Stefan also published his first paper about factorization machine, and he won a lot of competition without ensemble, just using his secret tool libfm, and then it's just like a huge wave, and just after like XGBoost, suddenly other people is using libfm. And in 2013, I started to touch sklearn, and I learned deep learning through PyLearn 2. And later, I started to craft the MXNet with Tianqi and Mu and Naiyan, a lot of friends. And we solved the distributed neural network training problem in 2013 to 2014. And in 2014, I started to write the XGBoost Python package and the Julia package, and we abandoned the SXNet and moving to design the next generation toolkit called MXNet. In 2015, I worked out MXNet mobile on iOS and Android, and also in web browser, which is kind of way ahead of industry, but it's my personal project. There's not a lot of impact. Then spent 2 years at Apple, working on some whales, and start from this year, I'm working on TVM. Probably you have heard of TVM, maybe or not. TVM is the deep learning compiler, and the TVM is able to generate the code. And I think TVM is very important work because it's the first step. We can see that program is able to replace programmer. So in my personal view, the success of the industry revolution is machine is able to generate machine. And I think the success of in the information era is program is able to generate a program. So by using TVM, TVM is able to generate deep learning operators much faster than the human crafted kernels, crafted CPU, GPU kernels. And like the new microarchitecture I proposed, TVM is able to generate code like 2.64 times faster than MKRDN. So I think it's a very exciting direction, but it's a little bit far away to the data science community. So we probably will talk about that in the future. So let's recall what happened in past 10 years. We already say, so I already showed that what I experienced in the past 10 years, but we can get some summary from high-level aggregation data. So this is the NeurIPS attendance figure, and we can see 10 years ago, and it's just like a small community, stable community. And from some stage, suddenly, and this community got exploding, and exponentially growing in this community. And it's coming to a cap. We can clearly see the cap. So also we can see CVPR is a computer vision community. We can see the same timelines, 2013, 2014, something happened, and then it's exponential growing. And if we do the derivative of these two functions, we can see that the derivative of the CVPR attendance and the NeurIPS attendance, they are almost the same. And what happened during the time, especially even a turning point, and what happened? Also, I found out another thing, which is following the same curve. So that's NVIDIA stock price. Yeah, and NVIDIA stock price. I sold all my NVIDIA stock price. I sold all my NVIDIA stock at a price of $30. And because I feel like from $20 to $30 is already a big growth. And I talked to Ian, and Ian, I agree. And then we both sold all the NVIDIA stock. And then at there's short time that NVIDIA stock dropping from $30 to $20, and it enforced our mind, okay, it's a peak. We are so smart, and we sold all the NVIDIA stock at $30. So, but later, and we can say that later the derivative is the same to the attendance of the conference. So that's a very high-level aggregation of data to reflect what happened in past 10 years. So I want to share some of my thoughts about my explanation of why it will happen, why there's a boost, and why there's a turning point. So let's recall how we did logistic regression, the basic model when we joined this community. I call an ancient era. So if we download 10 years ago the video and we learn something from that, this is how we do logistic regression. And we use a language called MATLAB or Octave, this language. And we needed to write down the function, and we needed to write down the gradient on the paper, and then write the code, and we need to write a vectorize the code, and this is and then when we have data, we needed to use a strange MATLAB or Octave function to read from file and then fit into the tensor, and then call this stuff to get a result. Once there's a mistake we made, we will get none, or it's not done converge. So this is the Asian era. Asian era, we have small data, and it's very hard to use. If we need to use, we need to at least know some math, and this is Asian era. So later, I call it the Renaissance era. Something changed, and this is most people, even for today, how we do logistic regression. We import from sklearn, and we do logistic regression, and then we just fit X and Y. That's all we do. And I call it the Renaissance era is because it inspired all the people later who make wheels, and how. So even we take a look of all the today's framework, no matter what model, we still fit in this interface. And by using sklearn, we are able to deal with the medium size of data, and it's very easy to use. And then suddenly, a lot of people join this community, and they don't need to know about a lot of math, and just call in library, import this sklearn, and problem solved. So it's good. So later, we come into the industrial era. Basically, they are same, but instead of sklearn, from some of my awesome framework, no matter what framework it is, from my awesome framework, we import logistic regression, and a little bit different. We can set something called a context. It's a 4 GPU or TPU or whatever, and something fancy. But the interface is similar, and it's the same. And then we make a logistic regression object, and then fit X and Y. By using the GPU, and then we are able to or accelerator, we are able to handle big data, easier to use, and then people focus more on problem instead of the wheel. Like when we do a logistic regression, who will ask, okay, what kind of framework are you using to train a logistic regression model? No one is asking that question today. So and then let's take a look of XGBoost. So this is the dark time of XGBoost, and XGBoost first appear, it looks like exactly same to libfm or liblinear, and it's a command line based toolkit. And when you have data, you need to use bash command to convert it into some binary file, and then use bash command to glue everything up, and then train a model. And if you want to change the gradient or gradient function, then you need to, or change the loss function, you need to write some C++. That's XGBoost for first appear. And then at that time, I told Tianqi, okay, that's not the way we should develop this toolkits. So I made this change happen, and import XGBoost as XGB, and then we have a Python interface, and we make changing loss easier, and later I fade out from XGBoost development, but I think today is still following this pattern, make it very easy for people to use, and then people are able to use XGBoost to train on large data and get a fancy result and do whatever modification you want. So it's a black history. When XGBoost was not well known, it's in the risky business competition. I secretly use XGBoost and spend 9 days in the competition. In public leaderboard, I'm the second place, and in private final result, I'm the 4th place. And the second person replying me, I think he's the CTO of LogicAI, and he's describing my work is your performance of the competition is nothing but amazing because other people they don't know XGBoost, and I can train much faster. And for the third people reply me, the PT is my friend, and he passed away years ago because cancer, and he's a very kind man and teach me a lot. And he's guessing I'm using some kind of deep learning tricks to win the competition. So yeah, that's before XGBoost was well known, and later and every people know XGBoost, and people are allowed to use XGBoost to solve the problem. So once we have XGBoost, we can solve problem with big data, and it's easy to use, and people are able to more focus on the problem instead of the wheels or system. And then we take a look of what happened in 2014, and it's a bloom of all the open source ML toolkits. Recall what the gradient boosting tree, like if you know that in early stage in 2011 or 2012, Yahoo has a secret boosting tree implementation. It's their top secret. But later on, the open source toolkits filled the gap between the public to the industry leaders. And then, especially after 2014, we have all kinds of toolkits: TensorFlow, Keras, Chainer, XGBoost, DYNet, Cafe MXNet, PyTorch, Cafe 2, Onyx, everything suddenly appear after 2014. Then let's take a look of this figure again. And there's a piece was missing, and but we can say there's a turning point is at 2014. After we have so many open source machine learning toolkits appear, and a lot of people are able to join the community, and then it leads to the bloom and the success of the AI, and it opens the door of the AI era. So every people are able to join this AI party. So we recorded the old linear model XGBoost, and then because I spend most of the time on deep learning stuff, so let's dig up some old story about deep learning frameworks. And I know Francisco will come talk later, but I will also mention Keras, but it's from my view. So how does a wheel maker think about DL framework? It's from my view. There's three major gear in a DL framework. It's performance and scale, and functionality and interface. So we can decouple all the DL framework in this perspective. And some focus more on one gear, and some focus on other gear. So it leads to different ending story. Maybe it's not ending story. It's just to some consequence because the different focus. So we can take an example of MXNet in 2015, and in MXNet, people think more about performance and scale. So in 2015, and we spent quite a long time thinking about how we can make a fastest framework and with best scalability. And then the consequence is this is NVIDIA's benchmark. Even there's no major change in MXNet core engine since 2015, but since until today, and the performance is still extraordinary compared to other frameworks. So that's that's a focus point to lead to this result. That's a story about MXNet. However, when people are new to this field, and the natural question is how we can start. Like when deep learning suddenly appear, only few people know deep learning. This neural guys, this nerd, they talk about deep learning. Other people has a secret weapon, like Ilya, he has, and Alex, he has his C++ implementation. Charlie Tang, he has his secret implementation. Other people has a secret implementation. So when deep learning appear, how can we start? And this is a very common discussion. Like, have you heard of deep learning? It's very powerful. Like two-layer neural network is able to mimic approximate all the functions. It's all powerful. And then other people were asking the question, oh, really? How I can start? So yeah, so we know something new, something powerful, and how we can start. So this comes from my view. It comes from Keras. And Keras spend more energy on interface. And I witnessed Keras growth since day one, and this is the summarized discussion of frameworks in Kaggle competition forum when Keras first appeared. It's 2015, and long ago. So I posted something about MXNet, and some other competitors reply, okay, MXNet is from XGBoost team. We love XGBoost, it's fast. And MXNet is super fast. And some people new come to the field asking, okay, oh, really? And I have 5 megabytes competition data, and I want to run 5-layer fully connected deep model on this data. But I want to modify the loss. How can I do it? This is a problem very common that in Kaggle competition. We need to modify the loss. We need to load the data, fit the data. Most of the competition data is not very large. And then at that time, MXNet is just made by a few people, and we don't have a very good operator coverage. And then the answer is, okay, if you want to modify the loss, you need to change the C++ loss function. And then compile it, you can get a good speed up. But this is what the user's feedback. Okay, enough. It only takes 5 lines of Python code with Keras. I love Keras. Why I should change the C++ operators? And this lead to great success, and some competitors that are very, very exciting to ensemble deep learning models into their in their result, and I mean, so they amplify this effect, and more and more people want to try Keras. It's convenient, it's flexible to change the operator, and even later, and the question becomes how to do deep learning, and the answer is just use Keras. So this happens a lot because like when my boss asked me how to do deep learning, why people are using Keras, is Keras equals to deep learning? Yeah, my manager asked that, and yeah, I need to answer that. But this is true that Keras focus on interface and lower the bar for most people to get involved into deep learning. Not everyone needs to train a model with 1 terabyte data. And most of the job is just tuning and fine-tuning with different loss. So Keras did a great job to get people touch the deep learning and then make progress on that. So Keras and XGBoost both from Kaggle, and by either winning a competition or providing the baseline tutorial to attract the new users. And also, we witnessed that both of Keras and XGBoost deeply changed the industry. And tens of thousands of people are using Keras and XGBoost every day. Like TensorFlow 2.0 use Keras as a default, even use Keras as default interface, means that it's great success. So let's recall the ML conference attendance. So I think there's something wrong with the display. And the next turning point is 2017. Something else happened in 2017. So it's the last gear is a functionality. Something happened in 2016 and 2017. So before 2016, and almost all framework are not Turing complete, which means it's only able to run linear part like a cafe, or in MXNet, if MXNet at 2016 is even not Turing complete. And TensorFlow is the first symbolic Turing complete framework, means that you can use TensorFlow to write whatever you can express. And Chainer is the first Python in proactive framework with full autograd support, which means by using the power of Python, Chainer achieved to Turing complete. And then PyTorch start to mimic Chainer autograd function and become a great success by leveraging the momentum of Torch. So after 2016, all the framework support this eager mode and autograd Turing complete feature. So why PyTorch success? So it's common that people at the beginning of TensorFlow, just open source, most people feel, oh, it's the ending of the era, and because Google is so powerful, and what's the meaning of making the whales? But surely, Sumis observed many things that we can't see, many things people ignore. That TensorFlow is very hard. The symbolic functional TensorFlow interface is so hard to use. And by using PyTorch, you can leverage all the Python debugging and print function to make it easy to use. And assume we want to do some GAN or reinforcement learning with fancy tricks, and the TensorFlow is very hard to use. And using PyTorch, by leveraging the Python data structure, is very intuitive. And then that's what happened in the forum again. And I just switched to PyTorch. And using TensorFlow, I need to write 400 lines of code. I don't know what is Q and what is this, what is that. But what is workspace? I don't know what is workspace. What is this function? But simply writing 40 lines of PyTorch code, I can do the same thing of 400 lines of code of TensorFlow. And then people find out, oh yeah, it's great. It's great. So other people like PyTorch because it's intuitive. It's even lower bar to get people involved into this field and create what they want instead of learning a complex functional language. So it's a pity that in 2015, MXNet is designed with hybrid model, and we considered about eager and graph support. But we didn't realize the importance of autograd and eager mode until 2017. And today, all frameworks are moving towards to this direction, because if we want to deploy it to the production, we have to use the graph mode. But to make it friendly, we have to eager mode is more friendly to user. And so in system perspective, MXNet did some leading work, even like mobile or the JavaScript stuff is years ahead of TensorFlow's effort, but we made a mistake. We lost the opportunity, and but we are still working in this direction, still making whales. So after that, we can say all the three gears are kind of ready. What does it mean by ready? So let's say the interface, revise the interface. Interface from the user to easily use the framework to get involved into this industry. And in China, there's an AI textbook for kindergarten. And I haven't been back for 6 years. I don't know which framework they are teaching kids to do AI. But I assume that with today's framework, making blocks of CN or RN by using any of the framework is just playing like a Lego. It's just a toy. Even kids are able to build all the training blocks and solve their problems. That's real. It's not kidding. There's kindergarten AI textbook. Maybe years later it will be translated into English. So we can revise the performance. And yeah, when we first train ImageNet ResNet 50 is about 2 weeks. And some people publish paper about we can train ImageNet in 1 hour. And then people published a paper, and I can train ImageNet in 4 minutes. And these days, people are published a paper about, okay, I can train ImageNet in 74.7 seconds. So I assume that in this stage, performance is not an issue. If there's a performance issue, and it means that they are not doing in correct way, and there is correct solution to the performance issue. So if it's slow, that means it's not solvable. There's a solution. Just need to learn from what people did well and then get it fast. So revise the functionality. All frameworks are Turing complete, and all frameworks support both eager and graph mode. So every framework are same, and they are on same running line. They have same performance, same easy to use interface, and functionality is same. So which means I think framework are in good shape today. And unless there's a breakthrough, either in methodology or research, framework will keep the way how it likes today. And people were behind what framework you're using, just like we forget what we are using to train linear regression or logistic regression. People just focus on how we can solve the problem, how we can use our will to solve the problem. And this is the good or bad. It's kind of end of this will making era. And TVM is a different story, but I won't talk about TVM I won't talk about TVM today. But in framework level, I think the problems are solved, and we should focus more on the problem and how we can convert our model or research to production and make a real profit for the industry instead of only showing a number or making superstars in the social media. So let's say this figure last time. We can say there's a cap. Then it means we are reaching to a cap, and we have to focus on some problem to how to make real value of AI and make real value of our model. Otherwise, it won't grow as what we witnessed in past 10 years. Okay, that's all I want to talk today. I have 5 minutes. Do you have any questions? Thank you. Thank you.